Hello and welcome to the FireBIM beta tutorial run-through. In this video, I'll take you through the steps laid out in the riser diagram and calculations sections of our written tutorial for FireBIM so that you can get an idea of what it should look like as you go through each section. As I said, this will just be a run-through of part of the written tutorial, which also contains information about installing the FireBIM beta as well as some important background about how FireBIM functions within and what it expects from the Revit environment. I highly recommend checking out the documentation in addition to watching this video. The written tutorial is also where you'll find a link to download the project I'm using for this run-through. There will be a link to the written tutorial in the video description. Also, as I've said, FireBIM is currently in beta. That means, in part, that there will likely be changes during this period due to things like user feedback and planned polishing of features. As such, by the time you watch this video, the interface may have changed, and even the written steps I'm following right now may be different. Please forgive any discrepancies that may arise between when I'm recording this and when you're watching it. A final note. The riser diagram and calculations sections of the tutorial are written independently, in case you're only interested in one feature set or the other. I'll go through the riser diagram section first, then reset the project for the calculations section. If you are following along and choose to just keep going, that's fine. There will just be a few steps I mentioned that will be redundant for you. Also, there will be timestamps in this video for each of those sections. Now, without further ado, let's get into it. We're starting on the first floor plan view, which, as you can see, has some devices laid out, circuited, has the wires drawn. We'll begin by going to the FireBIM design ribbon, running the device edit command, and selecting the pull station down here by the building entrance. From here, we can go into the riser diagram graphics settings, set the group to manual fire alarm box, and the graphic to pull station. We'll exit, and exit again. And you won't notice anything right now, of course, but you will notice the effects of this once we start drawing the riser diagram. We also need to set the graphics for these smoke detectors, and one way you can do that is to right-click on one of the smoke detectors, go to Select All Instances, and select an entire project, which, as the name implies, will select all of the devices with the same family and type in the project. We'll run Device Edit again, and as you can see, it has all of those smoke detectors selected. When you have the list like this, you can go in and select individual ones, or select multiple ones to modify settings on all of them at the same time. Again, we'll go into the graphics settings, set the group to smoke detector, and the graphic to photoelectric. Again, exit out and exit. Now, doing that at the instance level here is one way to configure those graphics and other settings, but another way you can do it to front load some of that work and especially make it easier when you're dealing with multiple instances of the same sort of device is to make those changes in the device family. So let's take a look at that. I'll select one of our ceiling-mounted horn strobes here. Then I'll use Revit's Edit Family command to crack open the family. Then from the FireBIM design ribbon, we'll run FireBIM's Family Edit command. And similar to Device Edit, you can select the different types from this list. You can also select multiple types. So we'll set the riser group for this to notification, and the graphic to horn strobe ceiling mounted. As long as we're in here, since it does have a strobe equipped, we will also set the strobe to yes, and then we can set the output rating for each of these types. As you can see, 15 is already set. Set this to 30, and set this to 75. We'll exit out and then load that back into the project. We don't need to hang on to this device for later, so we can just load in and close, and we also don't need to save it. We'll choose to overwrite the existing version and its parameter values. And again, you won't notice a difference right now, but you will see the effects of this when we start drawing the diagram later. We'll also set up the family for the ceiling mounted strobes. So again, select it, run Edit Family, then run Family Edit, select all of the types, set the group to notification, the graphic to strobe ceiling mounted, and as before, set the strobe to yes, and set the output rating for each type. Exit out, load back in, overwrite, and now we're ready to start drawing our diagram. To do that, we'll go over to the drafting view for riser diagram that's already been created in this project. These lines won't be present in the tutorial project that you download if you're following along, but I do recommend doing something like this where you can sort of draw the framework of where everything is going to insert just to make sure it's a little neater, a little cleaner. Just to show how you can do that, you just go to Annotate and use Revit's Detail Line command. Then from there, you can set the line style you want and draw your lines as needed. To draw our riser diagram, we will use the commands on the FireBIM riser ribbon, beginning with the panel insert command. We'll insert the control unit, insert that right here. And as you can see, it comes in with the graphic and a label that shows the name of the panel. We'll run panel insert again. You'll also notice here the control unit, because it's already been inserted, is now highlighted in blue to let you know that it exists on a drafting view somewhere. We'll select the enunciator this time, press OK, and we'll insert that below here. These panel graphics are parametric, so you can use the grips here to adjust the size. Those are also connected to the parameters over here if you want to type those in instead. Now that we have our panels inserted, we can start inserting the circuits and devices on those circuits using the circuit insert command. We'll select the control unit, and it will pull up the table of circuits for that control unit. We'll actually start with circuit 3. Another note here for the wrap direction: if there are too many devices on the circuit for it to fit on a single line of the sheet, FireBIM will wrap the circuit around to make sure all of the devices get inserted on the diagram. This simply determines whether it goes up or down when wrapping from that initial line. We'll leave that as is, press OK. And because circuit 3 is on the second floor, I'll insert it up here and to the right. It will then ask for a second point, which will determine whether the devices are inserted to the left or to the right of that first point. The exact spot you specify also determines where the edge of the diagram is for that vertical wrapping I mentioned earlier. Select a spot way off here to the side. And there's our circuit with the devices on that circuit. And as you can see, where we set those graphics up in the family, they've come in with those graphics already set. We'll select the control unit, run circuit insert again, and because we already had the control unit selected, it knows to pull up the table for the control unit. We'll go with circuit 1, press OK. And that's on the first floor, so we'll start down here. Again, go off to the right, and there's that circuit. Now let's start working on our SLC circuits. So we'll start with 7. Which is on the second floor. And for the SLCs, we'll actually go off to the left. So select that insertion point, go to the left. And there's that circuit. Go again with circuit 6 on the first floor. And now it's just a matter of inserting the remaining circuits. And there you have our riser diagram. A few things to note. You may have noticed that a few of these tags came in with FireBIM instead of the information you would expect it to have. That's just because I'm running the software in trial mode, which will watermark some of the shared parameter outputs For text, it will replace it with FireBIM. For numbers, it will replace the number with -1. So if you see that while you're trying out the software, that's what that is. As soon as you purchase a license and activate that license, it will get rid of those watermarks and replace them with the values that are supposed to be there. Other things to note, the wires for the different circuits are a little messy. FireBIM will do its best to make sure that things are inserted neatly, but it's not going to get 100% there. That's why we do have all of the commands in the wires panel of the ribbon so that you can redraw those to look a little nicer. So with a little bit of cleanup, it can look more like this. From here, we can make changes to these devices that have been inserted on the riser diagram using the edit command. We'll select the strobe on this circuit, and we'll just change the type from 15 candelas to 30. And as you can see, that label has updated to show the new candela value. You'll see that some of these don't have actual fire alarm device graphics. They just have a square with a question mark. That is the placeholder graphic that we use for devices that have not been configured to show a different graphic. That is a default that is specified in our project options. It is a thing that you can change if you so choose, if you want there to be a different default graphic that comes in for devices that aren't configured. We can go ahead and set up some of these. So we will run the highlight device command. And we'll select this, which should be one of our addressable modules. And as you can see, running that command and selecting that device will show it to us on the plan view. You can also use that command going the other direction to find where a device on the plan view exists on the riser diagram. Now that we have these two here, we'll select them both. And you can use the device edit command on the design ribbon, or you can use the edit command from the riser ribbon. This will just smartly run the correct command for the type of device that you have selected. We'll go ahead and set those graphics. For addressable modules, we'll stick with the input-output graphic. And if we go back to the riser diagram, you can see that the graphics have been updated for those two modules. Let's dive into some of the customization options that we have available for the riser diagram. We'll start by going to the circuit types command. And this determines, among other things, which circuits will use which graphics on them for the end-of-line notations and for the graphics on the wires themselves. We'll start with the NAC circuit type. This is also just our default list. As you can see, there are buttons underneath to set up your own circuit types if you choose. We'll change our Class B graphic to resistor and say it has a default resistance of 15,000 ohms. Next, we'll go to panel control. We'll change the segment group to segment, which is what Project Options is already using, but setting it to segment then allows us to make changes to the graphic and type. Change the graphic to segment text, and the type to new solid. Finally, we'll go to SLC. Again, we'll set this to segment so we can modify the other options. Keep that at simple, and we'll change this to new dashed. We'll press OK to save those changes. Nothing has updated on the riser diagram, partially because right now all of these are assigned to the same circuit type. By default, they all will be inserted on the NAC type, but we can modify those types by using the edit command or the circuit edit command. We'll start with the SLC circuits. As with the other dialogues, you can select multiple circuits from this list. We'll change our type to SLC. And as you can see in the back, that has already caused some changes for the one SLC circuit here. Just to show what other changes can happen, we'll also set the class to A, which will insert a Class A graphic on the end of the line there, in case you want something like that to signify which ones are Class A on the riser diagram. We'll also go to the enunciator circuit, change the circuit type to panel control, and then when we exit, you can see that has also been updated to use the other family that we ship with that has inlaid text across the wire segment. You might have noticed that some of these things did update as we made changes to them. For instance, the resistor value has already been filled in. The circuits we directly modified have been changed. But there are still some labels that need to be filled in. The end-of-line graphics for the NEC circuits aren't quite right. The easiest way to make sure all of that stuff is up to date and pulling the latest information that we've set in FireBIM is to run the update commands. You can use update part of project to specify changes beginning at a certain panel. For instance, if you have a really big project and you are only working in one section of the building, you can use that to just update that section instead of taking the extra time to update everything. For this case, we will just use update whole project. It does ask for confirmation just because, especially with bigger projects, it can take a little while. So we'll run the update. And when the update finishes, all of the shared parameter values will be updated, as well as all of the riser diagram graphics. Next, we'll take a quick look at how the riser diagram lives and changes and evolves with your design. To do that, we'll go to the second floor ceiling plan, and we'll insert a new device. So let's go to the Systems ribbon. We'll use Revit's fire alarm device command. We'll insert a ceiling-mounted horn strobe, and we'll put it in the hallway here. Now, to circuit it to the same circuit as these other devices, we'll just select one of those devices. Go to Electrical Circuits, edit the circuit, then select this to add it to that circuit, and press the checkbox to confirm. As long as we're here, we'll also erase this strobe here. Now, if we go back to the riser diagram, nothing has changed yet, mostly because we weren't using any FireBIM commands just now. That was standard Revit functionality. So FireBIM doesn't know that anything has changed yet. We could use the update whole project command, but since the only change has been to that one circuit, we can make this a little faster by using the circuit update command. Select the circuit here, and here you can see the graphics have updated. The ordering is also maybe not what you expected. The reason for that, if we go to the second floor plan view, is that the wires that have been drawn on this plan, as you can see, have broken where that strobe got erased, and they do not connect to the horn strobe that we inserted. FireBIM uses these drawn wires to determine device ordering, so that is going to impact your riser diagram and is also going to impact your voltage drop calculations if you're using point by point. So real quick, I'll show you how you can fix that. Again, this part is standard Revit functionality, but it is something that you will need to know about to be able to use FireBIM effectively. We'll start by erasing these wires that we don't need. Then we'll run one of these wires commands. This is important. When it's snapping to the device you want to draw wires from, make sure it snaps to a point, because that point corresponds to the electrical connector for that device. If it's not connected to the point, then Revit will not recognize that you're actually drawing from that circuit to the circuit on the other device. So we'll select that point. Then we'll select the point on our horn strobe. You could, of course, use this drawing neater lines. I'm just doing the quick version here to show you. Because we connected from the point to the point, it will stop drawing the wires for us because it understands that it's drawing from one electrical connector to the other. So again, we'll select the point on here to start from that connector. Then we'll go to the point on this one. And we'll exit out. And if we update that circuit again, you can see now that those devices have been rearranged to match the wiring on the plan view. That does it for the riser diagram portion of the tutorial. We'll do a quick reset, then go through the calculations section. To start configuring your project for FireBIM's battery and voltage drop calculations, we first need to set the alarm loads on our devices. The simplest way to do that for our circuited devices is by running the device edit command and selecting the device, such as our pull station here. As you can see, we have spots to define the standby and alarm load. If the device has multiple connectors, such as a speaker strobe that uses a 4-wire configuration, you also have the drop-down to select the connector, assuming those connectors are defined in the family. We'll set the standby load here to custom, and we'll do 0.2 milliamps. We'll also do 0.2 for the alarm load. We'll exit. Of course, you won't notice any changes at this point, but when we're actually running the calculations, you will see those changes that we've made. We can also set the current draws for our smoke detectors. One way to just quickly knock that out for all of them is to right-click on one of them, go to Select All Instances, and select an entire project. As the name implies, that will just find every device of that same family and type throughout the project and select it. And when we run Device Edit, it will come up with all of those devices already selected. And from this list, you can select specific ones or select all of them, so that any changes you make occur to all of the selected devices. And again, we'll set the standby load. We'll do 0.3 milliamps for these. Same for alarm. And exit. Now, that works for doing individual instances, but you can front load some of that work and make it a little easier for yourself, especially when working with multiple instances, to go ahead and set these values in the family. So that's what we'll look at next. To start, we'll go with this ceiling mounted horn strobe here. Then we'll run Revit's edit family command. Then we'll go to FireBIM design and run the FireBIM family edit command. As with device edit, there's a list here of all the types in the family, and you can select multiple of these to make changes to several of them at once. Because these do have a strobe, we can go ahead and set the strobe to yes. And here we can set the output rating for each. We'll start with a 15 candela. That part's already good. We'll also go ahead and set the alarm load for this to 120 milliamps. And we'll set the 30 candela to 135. And the 75 to 160. We can load that back into the project. We don't need to open up this family again, and we also don't need to save it for future work. So I'll use load and close and not save it. And when we overwrite, we'll do existing version and its parameter values. Again, not going to notice any change right now, but the work that we're doing will become apparent when we start running these calculations a bit later. Now let's do the same thing for these ceiling mounted strobes. Again, edit family, then family edit, select all of the types, and set the strobe to yes. Then we can set the values for each of these types. For the 15 candela, that's 90 milliamps. For the 30, that's 110 milliamps. And for the 75 candela type, that's 140. Again, we'll load in and overwrite. Now for the battery calculations, in addition to the load from the circuited devices, there are, of course, the internal components to the control unit that also need to be factored into those calculations. So to do that, from the FireBIM design ribbon, we'll run the panel edit command, which will bring up the list of all of the things that FireBIM considers a panel in the project. Generally just anything that can have other devices circuited downstream of it and is set up in Revit as an electrical equipment will be recognized as a panel. So for the control unit, we have the table here where you can, again, specify the loads for those internal components. So let's define a few of those. We'll call this the main circuit board. Set the standby to 170 milliamps and the alarm load to 360. And we'll say there's one of those. Now we'll add in a few more. And then we'll exit to close the dialog box. As with our circuited devices, you can also set these internal panel loads in the family. So to show that, we'll select the enunciator. Again, go to Revit's Edit Family command, run Family Edit, and here you can see that table again, with the notable exception of the quantity column. That is something that still gets set at the instance level in the project. So let's define a load here, call this main unit, with 50 milliamps for the standby and 60 for the alarm. We'll exit out, load back in, overwrite, and if we select the enunciator and run panel edit, you can see here there is now a new table that specifies those family level loads. We'll set the quantity for that to 1, then close the dialog box. Now that we've defined some of those loads, we can go to the calculation schedules drafting view and insert our battery calculation schedule using the battery schedule command. We'll select the control unit. This does allow you to select multiple panels if you have several devices that are going to be running off of the same battery. We'll just stick with the control unit for this though. Up here you can set the title for your schedule, the subtitle. This section right here will autofill with the name of whatever panels you have selected for the schedule. You can also set a note to appear at the bottom of the schedule, and here you can modify the list of panels that are included in the calculation. You can also press the button here to go to our project options command and to the specific section where you can customize these schedules. For right now, we'll run with the defaults, press OK. And wherever we select on the drafting view is where the upper left corner of that schedule is going to pop in. And here you have the battery calculation schedule. You might have noticed that some of these values, instead of displaying what you would expect, are just displaying FireBIM. That's just because I'm running the software in trial mode at the moment, which will watermark some of the outputs. For text, it will usually replace it with FireBIM. For shared parameters that are numbers-based, it will do -1 instead of the number it should be. That is just a temporary measure for the trial. If you purchase a license and install that license, then the next time you update things, all of those watermarks will go away. Now, to see how this thing updates and lives alongside your fire alarm design, we'll go to the second floor ceiling plan, and we'll just erase the strobe right here. Now, if we go back to the schedule, we can run the schedule update command to make sure it's showing the latest information that we have. Select the schedule, and you can see one of the rows just went away and the final calculation values have updated accordingly. As previously mentioned, there are some customizations you can do to these schedules. We'll take a look at that by going to the customization dropdown and project options. Down here we have all of the schedule settings that just affect how the schedule looks when it's on the drawing. We do also have settings to impact the calculations themselves. We'll change our alarm time from 15 minutes to 5. We'll say we're running off of a different standard than NFPA 72's latest edition, which says a 25% safety factor, and say this one just needs a 20%. Lastly, right now it shows everything in amps for the body of the table. We'll set that to milliamps. it will still show amp hours for the actual battery capacity. We'll press OK and update the schedule again. And now you can see the alarm time has been updated, as has the safety factor and the unit used to display the load values in the body of the table. Next, we'll take a look at the voltage drop schedule. So we'll run the voltage drop schedule command. Works similar to the battery schedule command, where you can select your different devices. We'll stick with just the control unit. Again, title, subtitle, note to go underneath, list of panels you can add or remove. We'll press OK, and we'll insert it right next to this schedule. One thing you may have noticed is that we do have all of these circuits for the control unit included in this schedule, including the SLC circuits and the circuit going to the annunciator, which we don't necessarily need. We can fix that by running the circuit edit command. We'll select the SLC circuits here. As with some of the other dialogues, you can select multiple items in this circuit list. And we'll go to the circuit types. This is the default list of circuit types that the FireBIM customization comes with. You can modify those circuit types and how they behave. We look at that a little more in the riser diagram section that we went through previously. We'll set these to SLC, and then we'll select circuit 8, and we'll set that to panel control. And you'll notice for the voltages across those circuits, it now says not calculated. So those will not be included in the voltage drop calculations. We'll exit, update the schedule, and now you can see those circuits are gone, and it's just our NAC circuits on the schedule. Let's take a look at some of the changes that we can make and how those impact these calculations. We'll go back to our ceiling view here. Go to the Systems tab, use Revit's Fire Alarm Device command to insert a new ceiling-mounted horn strobe. And we'll just stick that in the hallway here. We can put it on the same circuit as these other devices by selecting one of those, going to the Electrical Circuits ribbon, then Edit Circuit, and select the new device. To add it to the circuit, and press the check mark to confirm. We'll also make some changes to this circuit here. If we select one of the devices, then run circuit edit, the command will recognize the selected device and just pull up that circuit for the device when we run the command. Right here we have options to set the makeup length at each device, that is the additional cable that is used to make those connections, not accounting for just the distance from one device to the next. For example, if you're using drop ceilings and so it needs to go up, over, and then back down. We'll set this to yes, so the makeup is applied to all of the devices. Otherwise, it only adds the makeup from the panel to that first device. So we'll do that. And then just to show off how this can affect our voltage drop calculations, we'll set some crazy number like 200 feet. You might have noticed a couple of changes there. The end-of-line voltage, of course, updated. Using the number 18 wire, it would have dropped below 16 volts, which is the minimum we have specified in the project. And so it upsized the cable from number 18 to number 16 so that it's keeping the voltage at the last device above that 16 volt mark. And if we exit out here and go back to the calculation schedules, then update the schedule, you can see for circuit 4 how it is now showing those number 16 wires between each device. And over in the voltage column, it is showing those updated values, as well, of course, the voltage drop and the resistance. Now, if we go back to the circuit, right now it is set to just automatically select the optimum cable size for the circuit. If we go back to number 4 and we specify a wire, it will use the wire that we specify regardless of what the calculations come out to. So we'll exit, update again. And now you can see at that last device, the voltage does fall below that 16 volt minimum. And so FireBIM is going to highlight that just to make sure you are aware of where the problem lies. And you can decide at that point if you need to do anything about it. You also might have noticed on circuit 3 that horn strobe that we put in is being placed at the end of the circuit, even though it would make more sense for it to actually go in the middle for how we specified it. The reason for that is because we didn't use Revit's wire commands to actually set up how that wire is arranged, how those devices are ordered for this calculation. So for those calculations, just make sure that you are using the wire commands to make those connections. If you need to see an example of that, I did go over that in the riser diagram section. As with the battery calculation schedule, we can also go into project options to customize the voltage drop schedule. We'll set the minimum circuit voltage to something higher, like 19. We can also change the calculation method. Instead of calculating the voltage and resistance at each device, we can have it set the full load of all of the devices on the circuit at the end of the circuit and calculate it that way, which tends to produce a more conservative result if that's what you would prefer. We'll press OK to save those changes. And when we update, you can see how the schedule has changed. Instead of showing the voltage across each device, again, now it just puts the entire load at the end, determines what the voltage would be in that scenario. You can also see how the minimum voltage has changed, which will come into play in just a moment. For the resistance values, you can modify those in the cable types command. These are the cable types that are included in the default customization. You can, of course, create new ones, remove these, and make modifications to the wire sizes we have defined. Let's say the wiring that is coming from the manufacturer you're using for this project has much higher resistance for their number 18 wires, like 12. We'll exit out, run the update, and you'll notice that most of these wires, except for the one circuit that has no load on it and the circuit that we specified to remain at 18, all the rest of those wires have been upsized to number 16 to make sure the end-of-line voltage stays above those 19 volts. That concludes this tutorial run-through for the FireBIM beta. If you have any questions or comments about this video or about the software, you can leave them on this video or use the link in the description to go to our contact page. There will also be a link to our product page if you want to get more information about the software or if you want to get to links for reporting bugs and adding things to our wish list. Take care.